This is Algebraic Expressions Part 1. When I say algebraic expression, I'm talking about an algebraic problem whose answer depends on the value of the variable. So for example, 6n plus 7 plus 4n plus 8 can have a different answer depending on the value of n. Whatever n is worth dictates what the answer is going to be for this expression. Let's talk about some of the parts of an expression. So when we have an expression that is separated by addition signs, each part of that algebraic expression is called a term. So in this case, I've got addition signs separating these different pieces. So 6n is a term, 7 would be its own term, 4n would be a term, and 8 would be a term. Coefficients are the number parts of a term with a variable. So 6n is a term with a variable, n is my variable, and the number part of this term is 6. So 6 is called a coefficient. I also have 4n, this is also with a variable, and the number part of this one is 4, so 4 is called a coefficient. Constants are terms without a variable. So 7 was by itself, no variable, and 8 was by itself, no variable. So we call those constants. Substitution is when we put a number into an expression in place of the variable. So let's say that we're going to say n equals 1. So 6 times 1 would give us 6. 4 times 1 would give us 4. And now I just have to do 6 plus 7 plus 4 plus 8, and I get a total of 25. So let's look at a few problems and let's identify the terms, the coefficients, and constants. Remember, in order to do this, all of the terms need to be separated by addition signs. Sometimes that's not the case, and I have to do a little of add the opposite in order to make my problem an addition problem. So let's start with this guy. We've got 9x, and then we come to a subtract. I'm going to change it to add the opposite. So 2 is going to become negative 2. And then I can keep going. I have plus 7. Oh, I have another subtract, so I'm going to make this plus negative x. So I changed, anytime I saw subtract, to add the opposite. Now this guy right here, he just says minus x or negative x. I can put a number in there. There's always a number. In this case, it's a 1 because a single x is just 1x. So I like to add in that number right there. So my terms are 9x, and that is being added to negative 2, which is being added to 7, which is being added to negative 1x. My coefficients are the numbers that go with variables, so 9 in this case and negative 1. And constants are the numbers that are by themselves, so negative 2 and 7. Let's try one more. So as long as it's addition, I'm good, but if I run into any subtraction, I'm going to have to change it to add the opposite. So my first subtraction here, I have minus 3x squared. So I'm going to make this plus negative 3x squared. And then I have a z by itself and a z squared by itself. Since they're just singles, I can just add a 1 in front. There's just one of them. So my terms are 1z squared, which is being added to 5z, which is being added to negative 3x squared, which is being added to 1z. And coefficients are numbers that went with a variable. So in this case, every single one has a variable. So my numbers are 1, 5, negative 3, and 1. Constants are numbers that are by themselves, and in this case, I don't have any numbers that weren't with a variable, so there are none in this problem. No constants. All right, substituting in an algebraic expression. So here I'm being given the algebraic expression 6x plus 2y. And they're telling me what x is and what y is. So the first thing I'm going to do is I'm going to substitute. Instead of x, I'm going to put in -3. And instead of y, I'm going to put in 5. Then I'm going to solve. So I have to multiply first. So my multiplication here will give me -18. And my multiplication here will give me 10. And then lastly, I will add, and I get -8 as my final answer. Showing all my work there. All right, now I have a little bit more difficult one. I have 6x squared minus 3 times y plus 2 plus 8. So I'm going to substitute in anywhere there's an x, I'm going to put in a -2. Anywhere there's a y, I'm going to put in a 4. And I'm going to follow my order of operations. So the first thing I have to do is my parentheses here. So I have 3 times 6. Now I'll do exponents. -2 times -2, I get 4. Next, I will do my multiplying. So I have some multiplying here, I get 24. I have some multiplying here, I get 18. So 24 minus 18 is going to leave me with 6, and 6 plus 8, I'm going to get 14 as my total. Lastly, let's look at some real-life applications. So let's say each student in your class had to do 14 homework problems. How many problems will your teacher have to grade? They're asking us to define our variable and write an algebraic expression. So I'm going to use S. And S is going to stand for the number of students in my class. I have to explain what S is going to stand for. Now that I've defined my variable and I know each person has to do 14 questions, I can say it's going to be 14 times S. So however many students I have times 14, that's how many problems my teacher is going to have to grade. Let's take a look at this one. You can read 52 pages per hour. You must read 130 pages for homework. Can you complete the assignment in 2 hours? Explain your reasoning. So I can read 52 pages per hour. So H is going to stand for the number of hours I'm reading. So I can do 52 times H. Okay, now I only have 2 hours to read, so I'm going to put in 2 for my H. And that gives me a total of 104. Well, I need to read 130. So I'm going to say no. I'm going to explain no. I can't get the reading done. Because in 2 hours, can't get the reading done in 2 hours. Oh, hold on. I can read 104 pages in 2 hours. Not 130. That would be my reasoning.